Hello, my dear students. This is Dr. Vivek Rohira's mathematics mentor. Today, I will introduce you about the chapter number 7, integrals. And in the integrals, our first topic is fundamental of integrals, that is the introduction. So let we start about the chapter number 7, integrals. And in the integrals, today I will introduce you about the fundamental of integrals. So what are the fundamentals? Okay, this we will learn in this lecture. And before starting fundamental of integrals, firstly you should know that is where integrals play an important role in the mathematics. So let's see here. So you should know that integral helps us to solving two types of problems. The number one, the problem of finding a function when its derivative is given. That is, whenever we have to given the derivative of a function, then we can find the antiderivative. The problem of finding a function when its derivative is given. I want to explain you this by an example. If we know the derivative of a function, that is d by dx of sin x is equal to cos x. So what is the meaning of this sentence? That is, we have to given cos x. We have to given cos x, and what we have to find? We have to find sin x. So in this type of problem, integral help us. Okay, so we have to find the function sin x when we have to given cos x. Second one, in the second, we have to find the problem of area bounded by the graph of a function under certain condition. That is, whenever we have to find the area of bounded region, then we use the integrals. And in the integrals, we use the definite integrals to find the area of bounded region. So sometimes we have a problem like we have to find the area of a circle. Okay, we draw the axis, that is y-axis and x-axis, and we have to find the area enclosed by this circle. So whenever we have to solve or we have to crack this type of problem, then we use integrals. Okay, so these are the two most important and key points. For that we are going to start the integrals, right? The next one is, we should also know that integral as an inverse process of differentiation. As in the first slide, we studied that we have to given the derivative and we have to find the function for which the derivative is given. So this is called the inverse process. So integral as an inverse process of differentiation. Okay. Now, when we have to given a derivative of a function, as previously we studied that we have to given the cos x, and we have to ask to find its original function, that is sin x, or that is called primitive or antiderivative. Okay, again I just write down d by dx of the same example I'm write down here. D by dx of sin x is equals to cos x. As earlier we discussed, that is, this is we have to given, and we have to find that original function. This function sin x, which we have to find out, this is called primitive or antiderivative. This is basically we have to find. And this process to find the antiderivative, we discussing about this process. So this process is called integration. that is to find the integral of any function. That process is called integration, and where the integration is taking as a base, then this type of calculus is called integral calculus, and where we are taking differentiation as a base, then this type of calculus is called differential calculus. So here we are going to start about the integration. Then in the higher classes you will study about the integral calculus. So here we understand that is integration or integrals is a inverse process of differentiation, right? Now we go in the depth to understand this definition more clearly. So we take an example. We have to given that d by dx of x raised to the power n is equal to n into x raised to the power n minus 1. This differentiation we know very well, okay? So d by dx of x raised to the power n plus c is also equal to n into x raised to the power n minus 1. The meaning is that when we are going to add any arbitrary constant, in the function x raised to the power n, then again we got the same result. So what we conclude by that? We conclude that this is one of the member of antiderivative, one of member of antiderivative of n x power n minus 1. This is one of the member of antiderivative, okay? And when we add any arbitrary constant c, then this is called family of antiderivative. Family of antiderivative. So whenever we are going to study about family of antiderivative, then this is called indefinite integral. This is called indefinite integral. So here also this is written that antiderivative of these type of function are not unique. There are infinitely many antiderivatives of these type of functions. So when we are going to discuss about family of antiderivative, that is we are going to introduce a constant of integration. This c is called constant of integration, and this capital C belongs to set of real number. So that's why we are just going to saying that there are infinitely many antiderivative of these type of functions. So here from the exercise 7.1 to 7.7, we firstly studied about the indefinite integrals. Okay, so this is we have taken an example to understand the definition of antiderivative. So n into x raised to the power n minus 1 is called derivative, of x raised to the power n, and x raised to the power n is called antiderivative of n into x raised to the power n minus 1. So by this example you understand very clearly about the definition. Now we take this definition in the journal approach. So in journal we can say that d by dx of capital Fx plus c will be equal to small fx. So small fx is showing derivative of capital Fx plus c, and capital Fx plus c is showing the family of antiderivative of small fx. So this is the journal definition. So here capital Fx plus c define a family of antiderivative of small f, right? Also, antiderivative of function of f, we use the symbol now. Symbolically, how we represent antiderivative or integral, or we can say indefinite integral. So this is the symbolic presentation, or this is a symbol to present indefinite integrals. So indefinite integral of fx dx will be equal to capital Fx plus c. So this capital Fx plus c is called antiderivative. This is called antiderivative of small fx. Okay, and this small fx is called, this is called integrand. This small fx is called integrand, right? So the process of finding the integral is called integration. Okay, so this is called integrand, and this c is called constant of integration. Constant of integration, and this is the sign of integration, and dx is called variable of integration. This is called variable of integration. So this is the general definition of indefinite integrals, that is you should know. That is integration of small fx dx will be equal to capital Fx plus c. So okay students, I think you understand this definition. So now we move to some standard formulas. Now we are going to learn about the standard formulas of indefinite integrals, but you should also know that all the standard formulas of indefinite integrals we can easily derive from the standard formula of derivatives. So one by one we study and understand which standard formulas at the initial level you should learn. So the number one, d by dx of x raised to the power n plus 1 over n plus 1 will be equal to x raised to the power n. So we know that the differentiation of 1 upon n plus 1 x raised to the power n plus 1 will be equal to small x raised to the power n. Now by this differentiation definition we can find antiderivative. That is, what is this one? This is antiderivative of x power n. When we say antiderivative of x power n, that is we apply the symbol of integration on x raised to the power n with respect to x. So we are using the variable dx. So the first formula we are going to write down integration of x raised to the power n dx will be equal to x raised to the power n plus 1 over n plus 1 plus c, where small n is not equal to minus 1, because if we will put small n is equal to minus 1, then the result will not define. Okay, so this is the first formula. Now in this formula if we put n is equal to 0, so it will be convert in x raised to the power 0, and x raised to the power 0 is 1. Okay, so this is simply called integration of dx. So whenever in the calculation we introduce any integration of dx, or we have to given somewhere in the calculation integration of dx, so we directly put the result is equal to x plus c. So this is an important concept from this formula. Also, now the second formula, integration of e raised to the power x dx will be equal to e raised to the power x plus c. About that function we know very well, that is if we do the differentiation of e raised to the power x, this again got the e raised to the power x. Similarly, if we integrate e raised to the power x, then we got the same result, e raised to the power x plus c. Now in the first result we can also just put different values of n, and we got some different result. We will discuss further about that. Okay, so this is the second standard formula. Now my dear students, the standard formula number third, That is when we will put n is equal to -1 in the formula number 1. Okay, it is not defined, but at n is equals to -1, x raised to the power n convert in the form of 1 upon x dx, and the integration of 1 upon x dx is log mod x of base e or log x base e. This also can be written as ln x plus c, or you can simply apply ln mod x, or here you can also apply mod x plus c, because we know that differentiation of log x is 1 upon x with the condition when logarithm having the base e. Whenever you do not have to be given any base, then you have to be pre-assume that the base of the logarithm will be small e. Okay, this is the third formula. Formula number 4, integration of a raised to the power x dx will be equal to a raised to the power x over log a plus c. Whenever you learn these formula, you should memorize that the differentiation of a raised to the power x is a raised to the power x log a. So by the help of these formulas, you can easily find this result. Okay. Formula number 5, integration of cos x is sin x plus c. Formula number 6, integration of sin x dx is minus cos x plus c. Formula number 7, integration of sec square x dx is tan x plus c. Formula number 8, integration of cos x square dx is minus cot x plus c. Formula number 9, integration of sec x dx will be equal to sec x plus c, because simply if you make the differentiation of sec x, then you will find sec x into tan x. Formula number 10, that is integration of cosec x cot x dx will be equal to minus cosec x plus c. Next, my dear student, formula number 11, integration of dx upon root 1 minus x square will be equal to sine inverse x plus c, or you can write down minus of cos inverse x plus c, because we know that when we do the differentiation of cos inverse x, so the result is minus 1 upon root 1 minus x square. That's why we introduce minus sign here, right? In the similar way, formula number 12, integration of dx upon 1 plus x square dx will be equal to tan inverse x plus c, or it can be written as minus cot inverse x plus c. Next, the formula number 13, integration of dx upon x root x square minus 1 will be equal to sec inverse x plus c, or minus cosec inverse x plus c. So these were some standard formulas of indefinite integrals. So before starting the problems of indefinite integrals based on definition and based on standard formulas, firstly you should clear the definition, and also you should be confident about the standard formulas. So now we are going to start the problems, but before the problems you should also know some of the properties of indefinite integrals. So there are some of the properties of indefinite integrals. The number one property, that integration of f dash x dx will be equal to fx plus c, because we know that differentiation and integration, they both are the inverse process of each other. That's why if we do the integration of any differentiation of any function, then it will be again got the same function, that is small fx plus c. We understand this concept by an example. So we taken an example also. As we know that differentiation of x square will be equal to 2x. Differentiation of x square will be equal to 2x. Now this x square play role as a small fx, and this 2x play a role as a f dash x. Now what is x square? X square is antiderivative of 2x. So antiderivative of 2x will be equal to x square plus c. Now you compare each and everything and every symbol. That is, you will find that integration of f dash dx will be equal to fx plus c. So we prove this property very easily, right? The next property, my dear students, that is integration of fx plus gx into dx will be equal to integration of fx dx plus integration of gx dx plus c. What is the meaning of that property? If two or more function which we have to given in the form of addition or subtraction, then we separate all these function, and by separating all these function we can easily apply all these standard formulas and do their integration very easily. So in these type of function, when we have to given two or more function with addition or subtraction sign, then we can apply this property and easily find the integration. Next, my dear student, the third property is the integration of k into fx dx will be equal to k into integration fx dx plus c. The meaning is that here k is any scalar. If any scalar is going to multiply with any function, or we can say any constant is going to multiply with any function, then we can put the constant out of the integration sign, then we can easily do the integration of fx dx. So I think all these property you understand very clearly. Next, my dear student. Now we start some of the base problems based on definition and the standard formulas. So one by one we understand all the concept. So let's see. The question number 1, we have to find the antiderivative of cos 2x plus 4x cube. Now we know that neither 4x cube is a standard formula of integration or cos 2x. We know about the standard formulas, because we know the standard formula is integration of x raised to the power n, and also we know the integration of cos x, not cos 2x. Okay, so this type of problem at the initial level we understand. We do the integration of these type of problem by the help of method of inspection. Now what is the method of inspection? That is, we have to memorize, or we have to go some of the reverse process, that which function differentiation is cos 2x and which function differentiation is 4x cube. So by the help of this concept we can easily find the antiderivative of cos 2x plus 4x cube. So let's see how we solve this question. So firstly we know that differentiation of sin 2x will be equal to twice of cos 2x. So we got that function cos 2x, but 2 is also going to multiply. So we will take 2 on left hand side. So when we will take 2 on left hand side, then it will be divide. So it will be convert as d by dx of 1 by 2 sin 2x will be equal to cos of 2x. That is, by the standard definition we know that 1 upon 2 sin 2x is antiderivative of cos 2x. So cos 2x antiderivative we found. Now our target to find the antiderivative of 4x cube. So in the second step, this is the first one, and now second one. We know that differentiation of x raised to the power 4 will be equal to 4x cube. That is, x power 4 is antiderivative of 4x cube. Now we can combine both of them and write down not antiderivative. We apply the symbol of antiderivative. That is, integration of cos 2x plus 4x cube dx will be equal to cos 2x integration is 1 upon 2 sin of 2x plus 4x cube. 4x cube antiderivative, or we can say integral is x raised to the power 4 plus c. So this is antiderivative of cos 2x plus 4x cube. So I think you easily understand by the standard definition of integrals. So my dear students, next question, question number 2. We have to find the antiderivative capital F of small f, where small f we have to given, and also we have to given a condition, that is capital F0 is equal to 3. So before applying that condition, our first target to find capital F. Okay, so how we will find capital F? So I think that by applying the properties and standard formulas, we can easily find the antiderivative of small fx. So without any delay, we should start the problem. Solution. Integration of fx into dx, that is integration of 4x cube minus 6 into dx. Now 4 is the constant, we will take out of the integration, then this is integration of x cube into dx minus 6 integration of dx. Is it clear? Now we can easily apply the standard formulas. And what is this integration? This integration is nothing but this is antiderivative capital Fx. So the symbol we apply here, and also 4 x cube integration. So whenever we have to do the integration of x cube, then we should memorize that integration of x raised to the power n we have to apply, and we know that integration of x raised to the power n is x raised to the power n plus 1 over n plus 1. So it will be x raised to the power 4 over 4. Minus 6 is constant, and we know that integration of dx is x. Okay, so we just write down here x plus constant of integration c. So finally we found that capital Fx is x raised to the power 4 minus 6x plus c. This is equation number 1. Now you understand why this condition we have to given. This condition we have to given to find the value of constant of integration. Now f0 is equal to 3. What is the meaning of this one? This 0 define as x is equals to 0. And what is 3? This 3 is value of f at x is equals to 0. So we put x is equals to 0 and the value of capital F is equal to 3. So putting the condition f0 is equal to 3, we find 3 is equal to, when we will put x is equals to 0, then x power 4 is equal to 0, 6x also 0, then the value of c we find equal to 3. So we put the value of c, and when we put the value of c, then we find the final answer, that is fx will be equal to x raised to the power 4 minus 6x plus 3. This is your final answer. So I think very easily we find the antiderivative capital F by using the condition. So when we use the condition, we find the particular value of constant of integration. So when we are introducing constant of integration, then equation 1 shows the family of antiderivative of small fx. But when we put the value of c is equal to 3, then it shows a member of that family, right? So this is called a particular solution. So my dear student, we move to the next problem, that is question number 3rd. We have to find the integral of 1 minus sin x over cos square x dx with respect to x. Whenever in the word form we have to given the problem, then in this sentence given is integral, that is integration sign we have to use. With respect to x, that is the variable integration, we have to use x. So symbolically how we will write this question? So it can be written as integration of 1 minus sin x over cos square x into dx. Now we separate both of them. So it will be 1 upon cos square x, that is sec square x, sin x upon cos square x, that is sec x into tan x dx. Okay, now we know that we separate the function, that is sec square x dx minus integration of sec x into tan x dx. By using the standard formula, you can easily find the integration of sec square x is tan x. Integration of sec x tan x is, it will be sec x plus c. This is the indefinite integral, or we can say antiderivative of 1 minus sin x over cos square x. So I think now you easily learn that is how we apply the standard formulas. So the next problem, my dear student, we have to find the integral of square root of y plus 1 upon root y with respect to y. So whenever you are finding the integration, so you have to check two things. The number one, the function variable, and the variable in with respect to you have to do the integration. So here the function has the variable y, and also with respect to the same variable we have to do the integration. So it doesn't matter, okay, the standard formula will remain same and they will apply as it is as we studied. Okay, so do not confuse when the variable in the question is going to change. Okay, so let's see how we start the problem. We firstly write in the symbolic form. We apply the symbol of antiderivative or integral root y plus 1 upon root y into dy. We have to create an image like the variable x, and we have to think over the standard formula, that is which standard formula we can apply. Okay, so before that, first we separate the function root y dy plus 1 over root y dy. Now my dear student, on the right hand side we do some of the rough calculation and just understand about the integration 1 upon root y dy. So this is you have to be directly learned. Okay, but before direct you want to learn, you see that how we prove. We can write down it y raised to the power minus half of dy. Now y raised to the power minus half of dy can be written as y raised to the power minus half of 1 minus 1 by 2 plus 1 plus c. So finally it will be written as 2 by 3 y raised to the power, sorry, not 2 by 3, it will be 2. So my dear student, it will be 2 y raised to the power half plus c, or we can write down 2 root y plus c. So you should directly know that integration of 1 upon root x dx, or we can say integration of 1 upon root y dy, they will be equal to 2 root x dx, or we can write down 2 root y dy. So we do the same here. Now root y dy, root y, that is y raised to the power half. When we will put n raised to the power half, so the this will be changed as y raised to the power half plus 1 over half plus 1 plus this will be 2 root y plus c. Okay, now 1 by 2 plus 1, that is 3 by 2, so it will be written as 2 by 3 y raised to the power 3 by 2 plus 2 root y plus c. This is your final answer, that is the integration of root y plus 1 upon root y. I think you understand very clearly that is how you have to apply standard formulas, properties, So, and also definition, so you can easily find integrals or antiderivative of the given function. Okay, my dear students. So thanks to all of you, my dear students, for today's lecture.